Hello, we are Team EAT, Eternal Ag Technologies. We are coming to you from the UNH Dining Hall where we would like to address 3 social and environmental challenges. Those challenges are food waste, food insecurity, and greenhouse gases associated with food production. The unfortunate reality of living in the privileged world is the ability to waste food without considering the consequences. In the U.S., 40% of all produced food ends up in landfills. From a social standpoint, this is unacceptable, as 1 in 7 Americans is food insecure. Environmentally, food waste in landfills contributes to global warming, reduces storage capacity, and permanently locks away valuable nutrients. Our business model is to develop a self-sustaining composting and food production system that closes nutrient, water, and energy cycles while doing so in a manner that reduces negative externalities, is financially viable, and replicable here in New Hampshire and across the globe.
Our innovative composting system can be found here at the UNH Organic Dairy. The system works by placing food waste on top of a concrete pad with air channels beneath. We pull air through the compost piles with a fan system, allowing us to capture 150-degree compost vapor, which is also full of CO2 and ammonia. In the facility, contaminated vapor extracted from the compost piles travels through a network of pipes and is sent into a giant heat exchanger that warms water in a sealed chamber to 115 degrees. The system produces 150,000 BTUs per hour in heated water. After heat exchange, the remaining 100-degree vapor is off-gas to the environment. Our goal is to increase the return and environmental benefit by further extracting heat, CO2, and ammonia from the vapor using a greenhouse.
Here at the UNH Fairchild High Tunnels, cost of heat last winter was $9,000. If our system were attached to this greenhouse, there would be no issue heating it with just compost vapor. Beyond free heat, our system would remove CO2 and ammonia from the vapor by plant uptake, reducing greenhouse gas emissions from food waste. When the compost is finished after 90 days, it can be sold and another batch loaded for more heat. Outside of winter, the heated water would be used for domestic needs, meaning that our system is not seasonal.
When looking at our innovative composting system, 5 different revenue streams originate from the same unit of food waste. They include tipping fees, year-round crop production, carbon credits, compost, and liquid fertilizer. Our goal is to serve as a nonprofit to test this technology and provide information for free through reports and an interactive website focused on outreach. Our commercial-sized facility could be replicated for under $250,000, while smaller, less efficient systems could be developed for under $15,000. Our nonprofit will be funded through compost sales and crops sold at our facility, ensuring the website and reports will be available in the future.
Finally, we are a strong investment because there are few barriers for project startup. The legal framework for composting is established, and states across the country are now requiring composting of food waste. We are positioned extremely well to help farmers and municipalities process their waste using our multi-revenue generating system, while also increasing year-round food production and reducing greenhouse gas emissions at the same time.